Okay, so we'll talk about digital modulation. So some of the different modulation modes that we've talked about a little bit, I guess this, if I recall, is a little more in depth, little bit more on error correction and keying defects, specifically with Morse code or CW, some of the digital codes and spread spectrum, which now I guess we're allowed to do on, I believe it's 420 megahertz and above. Uh, let's see. Really, we talked about all this stuff. Overmodulation as a result of uh, too high a transmit audio level. Um, and one way to determine that is how much intermodulation distortion you're getting from the signal if you're overmodulating. They claim that for PSK, if you're idling or not modulating, that the intermod level should be minus 30 dB. So what's a common cause of overmodulation in audio frequency shift key signals? That's like FT8. Excessive transmit audio. What parameter evaluates distortion of an AF-SK signal caused by excessive input audio level? Dromedary. What's considered an acceptable maximum IMD level for an idling PSK signal?
71 plus. It's much higher than we say.
Keying defects. CW, right up your alley, Ed. One of them is called key clicks, which are spurious signals. If you're basically sending square waves. So one of the recommended things, at least by the ARL, is to increase the rise and fall times to 5 milliseconds.
Transfer across your key.
Well, that might do
I mean, you just take the key and you know it's 5
it. Or maybe you could put one of those compression type resistive things in the key, so when you press down, it changes the resistance instead of just making a contact. So here we go with our typical almost square wave key, although you can see there's just a little bit of rise time. And if you do the 5 millisecond thing, either with the straight trapezoidal or a raised sine type, there's not a whole lot of difference, but you get a little more rounding with on that corner with the sine type, so it's probably a little less distortion or less of a key click. What's the primary effect of extremely short rise or fall times on a CW signal? Yeah, you would think it generates harmonics too. But yeah, but I guess it's one of these cases where the generation of key clicks is a better answer than B.
Yeah.
It says, I guess they say the primary effect. You got to watch how they word these things. What's the most common method of reducing key clicks? Okay, digital codes. We were just talking about some of those. Uh, Basically, nowadays we use ASCII. Uh, I haven't actually looked at, you know what Unicode is? I don't either.
They haven't mentioned that, so they.
No, but it was just in the information I looked up. So they kind of treat them together. I don't know if it's a variation of ASCII or the
Unicode allows
international.
for international character sets other than just the standard English stuff or extended character sets beyond the standard alphanumeric stuff we use in English. So it'd be like the extra stuff. You'll see this in texting, for example, in the emojis, for example, instead of 128 characters that are allowed by ASCII, it gets into it uses multiple words or multiple bytes to represent a single character, so that it basically just extends the key set or the character set that's usable. But Unicode, there's 237, Unicode-237 is very similar to ASCII. You'll find those sometimes interchanged, but there's a whole host of different Unicode sets of information that are used to represent different languages and characters.
I
Good
think
to know.
German umlauts and things like that are included.
Okay. Well,
Yeah.
I guess since I've never done German or emojis, I didn't know about it.
But you can put your totals over your A's.
Yeah.
Yeah.
Okay.
Put your question marks upside down.
When we talked about the difference between Baudot and ASCII, Baudot was 5 data bits per character. ASCII is 7 or 8. You can have a parity bit. In both cases, they can have start and stop bits. And they, like we just talked about, on the shift code with Baudot, I don't actually know how it works, but it's my understanding that if you want to change to like uppercase or the special characters, you got to send a shift code character. And then to get back, you got to do an unshift code.
I don't think so.
Well,
I think you have to send the shift character and then the character you're shifting,
Okay.
and then the shift character. Oh, so it's back.
Isn't that what I
I
said?
think it's just for one.
Oh, it's not persistent.
I don't think it's a toggle.
Okay.
I think it's just
Okay.
the next character.
You might very well be right. I don't know.
Wrong.
Well, Sharon, do you know?
I found that mute button. What's the actual question there? I'm sorry.
On Baudot, how do you use the shift code?
I do not know the information. Sorry. That one's outside my knowledge.
We don't know either.
That must be a bunch of paper.
Once you shift the letters, it's gonna be all letters until you shift it to characters, and it's gonna be all characters.
Now, see, he agrees with me. He must be right.
Say I'm wrong, I'll guarantee you that's how it works.
He sounds pretty positive. Okay. Here's a part of an ASCII code chart.
If you think back to a teletype, how does a teletype machine work? It changes the cam for letters and characters, and the only way to get that cam to shift again is to change it.
Well, you push that button down, it shifts.
Yeah.
And you can get the key.
It's either all bits set or 1 and 2 and 4 and 5.
When you type, you hit the shift key. And then you hit the character you want to shift.
But if you
Both of them are down at the same time.
Right.
No,
No,
that's
it's
just
just
shift.
shift.
You have to do the shift first. That changes it. You gotta think of it as an old 28 teletype.
Yeah.
It changes the cam, And that cam will stay there. And you
Okay.
tell it to shift down again.
I thought you had to do it.
It's not like a computer. Once it's there, it's there.
He agrees with me,
Well, then,
I go back to the punch tape days,
but I don't remember much how the punch tape worked.
Navy teletype school,
That was a long time ago,
like about 50 years ago.
more than that.
I think there are two shift codes. One is for the caps and the other is for numerals. Um, I did a lot of Baudot back in the 70s, but not much since. I worked on the Morse to Baudot converter group for the Army Communications thing back in the 70s, but haven't touched it since then.
Yeah, I was doing the teletype in 67.
Mhm.
That was a while ago.
Yeah.
Okay. We all seen the ASCII code chart. A lot of the special characters up there. The original patented Baudot with their pluses and minuses instead of ones and zeros. I don't think this helps us on the because it only has looks like alphabet and a couple things after the Z. I can't make them out. But it's signed by Mr. Baudot. 1888. Been around for a while.
we didn't even put numbers on that original.
No. Maybe they didn't understand numbers back then. What are some of the differences between Baudot digital code and ASCII? We've been through this multiple times now.
So Baudot was 4-bit, and that's all.
I could be wrong.
I think it's wrong.
No, Baker.
Oh. No, I thought that, I didn't know it was a question.
Oh.
It's competing.
No, this is one where the longest isn't necessarily the right one because they're all long. But let's go with the standard 5 data bits and 7 or 8 for ASCII. What is one advantage of using ASCII for data communications? You can do upper and lower case. What's the advantage of including parity bits in ASCII characters?
Yeah.
Okay, spread spectrum was developed by the military for secure communications. Its intent was to make it resistant to noise and interference and all that good stuff, and unauthorized detection where you can't, even though you receive the signal, you can't decode it unless you have the right sequence. And there's 2 basic methods. There's frequency hopping, which is FHSS, and then there's direct sequence, which is DSSS. They both use very wide bandwidths, which is why it's called spread spectrum, because you'll see multiple frequencies over the band. The bandwidth is one of the reasons why they only allow it for amateur. I believe it's 420 megahertz and above. So it's basically UHF and a cell phone range, stuff like that. But I forgot when that changed. Amateurs are allowed to transmit spread spectrum. I don't have a radio that can do it, but
Not the transmitter, but not receive it.
Well, obviously, safer if you can transmit. So frequency hopping is they divided up the ISM2 band, that's the medical one I mentioned, part of the 2.4 gigahertz, into 79 1 megahertz channels. And they come up with this pseudo-random sequence of, 22 different pseudo-random sequences. And they pick one, and they're set up so that they have to use all of the 79 channels per cycle. So that's why it's kind of spread spectrum, because you're going to cover that entire 2.4 to 2.483 in that one cycle. But you don't know the pseudo-random sequence. That's one of the things that when you make the connection, you kind of bind the two transmitter receiver together so you know what sequence is being used. Nobody else does. And it changes rapidly. So in fact, the minimum is at least 2.5 hops per second, which means changes in the frequency sequence. So it doesn't give you a whole lot of time to try to capture what it is. And this is again where they use that Gaussian frequency shift keying modulation. I don't know what that really means, but it sounds important.
It's not in red.
It's not in red, but it could be that just when I brought the chart in, everything converted to black. The other mode is direct sequence, where they use this 11-bit Barker sequence instead of the pseudo-random sequence. And they modulate the carrier with that 11-bit sequence. And that's where you get all the different little frequencies out there. So in one case, you're shifting the frequencies rapidly, kind of going through them. In this one, you're kind of broadbanding a bunch of frequencies depending on that sequence pattern. And you use that, with modulate that with the data. It uses the binary phase shift keying to actually modulate. And it's again one that requires a linear amplifier. Since you care about the amplitude, you can't use a class C for that. They claim that the frequency hopping is more resistant to narrowband interference than the direct sequence. But direct sequence has a much higher data rate. It's more expensive, but I'm not sure what that means as far as more expensive. I guess maybe the equipment to do it. That just may be at the time it costs more. Yeah. Yeah, one of the big things it uses it is remote control airplanes and cars. You use spread spectrum now almost entirely. Yeah. Well, it allows you to operate multiple transmitters on the same frequency band at the same time. Used to, when it was 72 or 144 megahertz, you had to have a frequency tag. Yeah, and you're the only one that could transmit on that frequency at that time. It was just FM. So I don't even think you could buy the old stuff anymore. It's been spread spectrum for a couple of decades.
But would they interfere with each other if they're talking on the same frequencies?
No, because that's the whole purpose of spread spectrum. You got the different sequences, and the sequence has to match. That's why it's probably on the next slide. If it doesn't match, the receiver throws it away.
But everybody
Can be on the same
You
frequency.
could be transmitting at the same time.
Absolutely.
On the same frequency,
Absolutely.
and that doesn't interfere with anything?
No.
That's
One of the things to recognize is that spectrum frequency hopping means it's not transmitting on all of the channels it's using at the same time. It's literally doing a data
for the
burst
same
on one frequency for an instant, and then
Yeah.
You have
it switches to
79
yeah. So what
channels.
happens is
And let's say you got
for
20
go,
people on airplanes.
Okay.
There's a pretty good chance that at some time, two people's gonna be transmitting on the same channel at the same time.
But they have a different pseudo-random sequence.
Okay. So
So
they're gonna mess up. That's that
79
particular
communication
communication is
power.
gonna fail.
Yeah.
So they're gonna miss that.
Think of it this way, 79 to the 79th power is the chance.
Trust me, at a big fly-in meet, it's not a problem.
Well, I'm trusting you on
And
that.
I don't know if I've seen 20 at the same time, but a large number at the same time. And they're all in the same frequency band.
And the likelihood of two of them transmitting on channel 14 at the same time is,
Well, even if they do, the
The
sequence that they're using for that frequency is different.
yeah. So the next time they transmit, it's the wicked petty problem, maybe. Let's go on.
Okay. So what describes spread spectrum frequency hopping?
It's the delta duck.
I think that's what you're
Yeah.
trying to say.
Dotty dotty,
Huh?
dotty dotty. Dotty dotty. Dash dot dash dot.
Oh, you're talking that weird stuff. He's doing more stuff. Okay.
But it wasn't. I didn't read it correctly. I did one of yours. I didn't read them all. Oh, that's right, because yeah, frequency hopping is frequency shift. So what spread spectrum communication technique uses a high-speed binary bit stream to shift the phase of an RF carrier? You got that one? Why are received spread spectrum signals resistant to interference? It has to match the sequence, and otherwise it ignores it.
Is it the whole sequence?
Yeah.
So you've got a pattern from 179 or 0, whatever it is. And then the transmitter sends out all of those in that sequence. And then the receiver stacks it up and says, yeah, that corresponds to the sequence that I was expecting.
Well, it's my understanding as you're hopping through the different
Channels.
79 channels, okay, that each one you transmit on, you're sending this pseudo-random sequence that is part of the connection. You bind the transmitter and receiver for that connection, so you both know the sequence. So you send it, and then the next time you're a different channel, okay, but you're sending that same sequence that's known only to you and the other end. That's why even if somebody is on the same frequency at the same time, they don't have the same sequence that they're transmitting.
So each transmission of these 70 some things that get sent every cycle, it sends all 79 of them every cycle. Right?
No,
No.
no, it changes up to 2.5 times per cycle of the hops. Okay,
Transmitter and receiver are always on the same channel.
Yeah, I understand that.
right, because it has to know where to go.
Yeah,
So it knows to expect you on whatever the next number is, and it's kind of hard to wrap your head around.
It's just mine.
No, it took me a long time to kind of understand it. I've used it, I kind of understand how it works.
Radio?
No,
Oh.
remote control.
RC models.
Because you can use it in ham radio now.
Oh.
And you can use ham radio on the 2.4 to operate remote controlled vehicles. UAVs. UAS as they call them. You know, the drones. It's actually a UAS in the FCC. Unmanned aircraft system or something like that. When we get done, I'll show you what the license says. Okay. So, what did we learn? The PSK idling level was minus 30 dB. I don't know why that's important, but it's on the exam. Keying defects or key clicks, so you increase the rise and fall times to one way to fix it. We talked about difference between Baudot and ASCII and the error detection, which was usually a parity bit. Baudot has no parity bit, so you don't know on Baudot. And there's no retransmission on like RIDI, right? You decode it or you don't. And spread spectrum is a very wideband transmission. You have frequency hopping and direct sequence. I think the direct sequence is easier to understand, but except for the modulation part. And I'm not sure exactly what that looks like hardware-wise to do that. Any questions on those? Besides that we don't understand spread spectrum?